Hello everyone, welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us move on to the today's class. Today we are going to discuss about the solid shapes. Solid shapes, nothing but the shapes which are having three dimensions. Okay. So before that, let us discuss about the two-dimensional shapes. Okay. Now let us talk about a single dimensional objects, no dimensional objects, two dimensional objects, and three dimensional objects. First, no dimensional object. That means there is no dimension for that object, is nothing but a point. Point is no dimensional object or zero dimensional object. Okay. Next, that means there is no dimensions for point. Okay. So we are just using the point for identification of any location or what. Now, single dimension objects, there are one dimensional objects are simply the line segment and ray. The line segment and ray. So line segment and ray are single dimensional objects, nothing but one dimensional object. That one dimension is nothing but length. The one dimension is nothing but length. Okay, no? And line segment and ray also just a part of a line. Line segment and ray also just a part of a line, but they are not different from the line. Okay. So the one dimension is length. Here there are no dimensions. Here one dimension. Now coming to the two-dimensional object. How many? Two-dimensional object. Two dimensions. What are the two dimensions? Usually you are taking length and breadth. Length and breadth are the two dimensions objects. Okay? Two dimensions in the 2D objects. Now while taking the two dimensional object, there are so many two-dimensional objects will be there. Like triangle, quadrilateral, hexagon, pentagon, circle, all are two-dimensional objects. Okay, na? Like this board, that means the flat surface we are considering as a two-dimensional object which is having the length and breadth. But actual to the real part, real life situation, the board can be the three dimensions. Whenever the shapes are having the three dimensions, then only we are going to catch that. Okay, na? That means length, breadth and height. Three dimensions objects only we can take to our hands. And two dimensions object we can just touch and feel. Okay. So like two dimensions objects are like square, rectangle, quadrilateral, all types of triangles. So there are so many two dimensions objects. The dimensions are nothing but length and breadth. So that's why I am not writing the all two dimensions objects. But here we are discussing about some of the formulas based on 2D shapes. Like triangle formula, square, rectangle, parallelogram, trapezium, rhombus, okay, and circle, semicircle. These are all considered as two-dimensional objects. The dimensions are nothing but length and breadth. Okay, right. Now three dimensions of three-dimensional objects. The three dimensions are length, breadth are two of them, and the third dimension is height. Length, breadth and height. For example, this marker having the length, breadth and height also. That's why I am just able to lift this marker like this. The shapes which are having three dimensions, we can hold it in our hand. Okay, two dimensions we can just touch and feel, we cannot take to our hands. But three dimension figures are solids. Three dimensions are solids, we can take to our hands. Okay, na? So like three dimensions also we have, so many three dimensional shapes are there, but in this textbook we are having only some of the two dimensions objects, and let us discuss about their formulas. Okay, then we will go to the exercise problems. Okay, now for 2D shapes and 3D shapes I am writing the formulas here. So two dimensional objects. For two dimensional objects we should know the formula for area and perimeter. Area and perimeter. Okay. Right. So area means the shape or the region or a place which is occupied by a closed figure. Okay, na? The place or region which is occupied by a closed figure is called area. Perimeter, measuring the boundary of a closed figure. Measuring the boundary of a closed figure is called its perimeter. Okay. Now the two dimensions are given here. Triangle. First 2D shape is triangle. The area of triangle is half into base into height. Half into base into h, and the perimeter is sum of all sides. Sum of all sides. I am writing in a short form, just remember like that, sum of all sides. Okay, now measuring the boundary is nothing but sum of all sides. Next, coming to that right angle triangle or equilateral, there are some different type of formulas are there for isosceles triangle separately, right angle triangle separately, okay, and the regular triangle, equilateral triangle having the separated. But we are just stick to the regular formula, half base into height. Okay, whenever it is needed, I am going to express the formula in that. Okay, in the case of problems. So till then, just for triangle area formula, remember like half base into height, and the perimeter is sum of all sides. Next, coming to the square. Square area is side into side, or nothing but A into A, where A represents the length of a side. A represents the length of a side, and the perimeter is 4 into A. Because in square, all sides are equal, so A plus A plus A plus A, according to the perimeter sum of all sides are equal, 4 A's, 4 into A, 4A. Next, coming to the rectangle. Rectangle area is length into breadth, and the perimeter is 2 into L plus B. Area is length into breadth, perimeter is 2 into L plus B. Okay, na? Right. Now coming to the quadrilateral. Quadrilateral, nothing but square and rectangles, also the quadrilateral. Quadrilateral is nothing but simply the simple closed figure bounded by 4 line segments or 4 sides. Okay, na? Now quadrilateral. So I am writing it like short form. So quadrilateral area formula, half D into H1 plus H2, where D is nothing but diagonal. Diagonal means the line segment connected to two opposite vertices. Okay, na? The line segment connected to two opposite vertices is called diagonal. H1 and H2 are heights, or the perpendiculars drawn from vertex to diagonal. Perpendiculars drawn from vertex to diagonals in a quadrilateral. And perimeter is as usual, sum of all sides. Next, coming to the rhombus. Rhombus area, half D1 into D2. Again, D1, D2 are the length of the diagonals. Just now we have discussed what is diagonal. Okay, na? Diagonal means the line segment which is connected to two opposite vertices is called diagonal. Now here rhombus area is half D1 into D2, and perimeter is 4A. Here rhombus also, all sides are equal length. Now coming to trapezium. In a quadrilateral, one pair of opposite sides are parallel is called trapezium, and its area half h into A plus B. Half h into A plus B, where A and B are called length of the parallel sides. That means these two are length of parallel sides. Okay, and h is distance between parallel sides. H is nothing but distance between parallel sides. Clear till then? Right. Now, here also sum of all sides. Parallelogram. Parallelogram area, half base into height. Base into height is a area of parallelogram. Base means any one of the side. Height its corresponding altitude, nothing but the vertex. Altitude means altitude and height both are same. It is nothing but the line segment drawn from vertex to opposite side, but it should make 90 degrees angle at the point of contact. Simply the perpendicular line segment drawn from vertex to opposite side. Okay, na? And here also the perimeter of the parallelogram is sum of all sides. Sum of all sides. Here, I think these are enough for us. Still we should discuss about the circle and semicircle. The area of circle area of circle is pi r square, where pi is an irrational number. Here we can take an approximate value like 22/7. Okay, now r means radius of a circle. R means radius. Radius means center to the circumference distance. Distance between center to circumference is called its radius. Okay, now? And the perimeter is 2 pi r. Perimeter of circle is 2 pi r. Now coming to semicircle. Semicircle means half of the circle. Half pi r square. Half pi r square, and the perimeter is pi r plus d. Perimeter means measuring the boundary. Here arc, half of the arc will be so pi r, and this is diameter. So pi r plus d. Okay, na? Right. I think these are the formulas are enough to identify or to solve any problem in this exercise. Now let us discuss about the 3D shapes. Now 3D shapes, while you are observing the 3D shapes are nothing but they are having 3 dimensions like length, breadth, height. Now let us discuss about the all 3D shapes which are useful to your classes, further classes. Okay, na? So mainly we need to discuss about the 6 surfaces or 6 solid shapes. If not extra, some 1 or 2 or extra will be there. Let us discuss about all the solid shapes, and let us discuss about the Euler formula also. Then we will go through the formulas related to 3D shapes or nothing but solid shapes. Okay, na? Right. Now, 3-dimensional objects. 3-dimensional objects. Then breadth and height. The first one is cube. The first one is cube. So there are such type of solids. Some different type of solids are there. So simply nothing but cube, cuboid, cone, sphere, hemisphere, and here cylinder. Okay, na? Sometimes prism also will be there. Okay, triangular prism, rectangular prism, like that will be there. So let us discuss about these shapes first. First, the cube. Cube is made up of the squares. That means if you are taking square shape, we know that all sides are equal and each angle measures 90 degrees. So this square we are making into a closed figure, nothing but it is a box, shape of a box, like exactly will be this. Okay, na? So this is the shape of cube. All surfaces, all flat surfaces are same, nothing but squares. For example, if you wanted to check a square shaped or cube shaped room, if you are identify the room, there are 4 walls. Okay, na? So front, back, and right and left. So 4 surfaces, top and bottom. So total 6 surfaces. Each one is called surface or plane surface or flat surface. Okay, 6 surfaces. It is having 6 surfaces or 6 faces. F means face. 6 faces. And the connection of 2 surfaces. Okay, connection of 2 surfaces is nothing but forming a line. This is called edge. This is called edge. How many edges will be there? Now see, while you are observing here, just observe your room. There are 4 edges on a top, 4 edges on your base, nothing but floor. So 4 edges on ceiling, 4 edges on floor. So total 8. Now 4 corners, heights 1, 2, 3, 4. So total 12 edges. There are 12 edges. And this point, this vertex is called corner. That is nothing but the place which is joined by 3 flat surfaces is called corner here, or vertices. How many vertices are here? There are 8 vertices. So top 1, 2, 3, 4, 5, 6, 7, 8. There are total 8 vertices are there. Nothing but 8 corners. Okay. Now this is about cube. All flat surfaces are in the shape of square. That means it is bounded by squares. Okay, 3 dimensions are nothing but they are bounded by 2D shapes. Okay. Right. Now coming to cuboid. Cuboid also similar shape like a cube, but these are connected by rectangles or squares, a combination. Okay, rectangles or squares combination, or only rectangles also we can consider. Okay, that is cuboid. Same cube and cuboid having the same 6 flat surfaces, 12 edges and 8 vertices. Okay, now coming to cone. Cone is nothing but the shape like this, which is having the base shape. This is called base. Base is in the shape of circle, and this is having some cone shape. That means base with circle, and it is curved surface area, curved part, like a cone ice cream. Okay, now this is the shape of cone. Now coming to sphere. Sphere is nothing but a ball we can consider. This is sphere, curved area. While you are observing cube and the cuboid having the flat surfaces, but cone having the curved surface as well as flat surface at base. Base means a circle one, this one. I shaded the part is no, that is having a flat surface, and the remaining part is curved surface. But coming to sphere, entire curved surface only. There is no flat surface. Now coming to cylinder. Cylinder is a shape which is like a electrical pipe. Okay, na? This is like a cylinder shape. It is having flat surface and curved surface both. See, these are the top and bottom are connected by the circles, and this one as a curved place. Okay, so top and bottom having the flat surfaces, and the remaining part is curved surface. Cone and cylinder having both the surfaces. Cuboid having only flat surface, and sphere having only curved surface. But hemisphere is nothing but half of the sphere, so which is having the flat surface as a shaded part and remaining as curved surface. Now last prism. Prism is nothing but we can say like prism is cylinder also a prism. Cylinder is called circular prism. Cylinder is called circular prism. Okay. For example, if you take a coin like 1 rupee coin or 2 rupee coins, you are placing 10 coins on one another. So there is a formation of cylinder. That means what is the base? What is the regular shape of coin? Circle. On circle, we are keeping some other coins like that. There is a formation of height which gives the solid shape. Having the same base circle will be circular prism. Same way, if you take the rectangle, like triangle, if you take like this, if you place the multiple triangles on one another, there is a formation of prism which is called triangular prism. This is called triangular prism. Okay, na? Right. So now for flat surfaces, the solids which are having the flat surfaces, all the solids are definitely should satisfy the Euler formula. What is the Euler formula? F plus V equals to E plus 2. Nothing but faces plus edges. Faces plus vertices equals to edges plus 2. Now coming to the cube and the cuboid, 6 faces, 6 plus 8 vertices, 6 plus 8, 14, edges is 12 plus 2, 14, 14 equals to 14. So any flat solid or any solid which are having the flat surfaces, they must have follow the Euler's formula. This is called Euler's formula. Okay, na? Now let us discuss about the 3-dimensional shapes. The 3 dimensions having the lateral surface area, total surface area and volume. What is lateral surface area? We should take only the boundaries. For example, if you observe the cuboid, the 4 walls are considering as lateral surface area. 4 walls plus top and bottom. All surfaces, nothing but total surface area, and volume. Volume is nothing but the place or space which is bounded by the 3-dimensional object, or which are bounded by the created by the 2-dimensional shapes. Okay, na? So that means actually we are in the shape of we are in the space of or volume of cuboid, like that. Now let us discuss about the cube formulas. Cube having 3 different formulas. What are the 3-dimensional having 3 different formulas? First, cube lateral surface area. Cube is connected by squares. We know that area of square is a square. Like 4 walls are 4 squares, 4a square. Total surface area means top and bottom also included. That means 2 more squares added. So 6a square and the volume is a cube. Volume is a cube, nothing but length into breadth into height. Okay, now? Next, cuboid. Cuboid, lateral surface area formula 2h into L plus B. Total surface area formula 2 into LB plus BH plus HL. And the volume is LBH. And the volume is LBH, length into breadth into height. Now coming to cone or cylinder. Let me write cylinder first. Cylinder, this is curved surface area. This curved surface area, CSA, cylinder and cone are having, remaining all having CSAs. That means in the place of LSA, we should consider CSA, curved surface area. Okay, now? For cylinder curved surface area formula 2 pi RH and TSA 2 pi R into R plus H and the volume is pi R square H. These are the very important formulas to remember. Okay, now coming to cone. So cone formula is pi R L. CSA formula pi R L. L means radius, R means radius, L means slant height. Now in cylinder, H means height of the cylinder, R means radius. Okay, pi R L, then TSA pi R into R plus L and volume is 1/3 pi R square H. And sphere and hemisphere, there is no place here. Sphere and hemisphere, we will discuss the formulas when the problems are coming in the chapter. Okay, let us move on to the concept based questions. Right. The first one is, among the following which is not a two-dimensional shape. Not a two-dimensional shape. The options are circle. Circle is a two-dimensional shape. Second option, rectangle. It is also 2 dimensions, length and breadth. Square, 2 dimension. Fourth one, prism. Prism is not a two-dimensional object. So concept based questions. First one answer is prism. Okay, na? Prism is 3-dimensional object. There are different type of prisms. We are having that square based prism, triangle based prism, circle based prism, rectangle based prism. Square based prism is nothing but it can be cube or cuboid. Rectangle based prism is cuboid only. And square based prism means cylinder. Okay, na? So triangle based prism. Triangle based prism. Yeah, that means which are looking like yeah, I have already drawn the diagram, right? Yeah, like that. Next, second question, coming to the second question, that is, among the following is a 2D shape. 2D shape, first one sphere. Sphere means ball. It is 3-dimensional because we can take it to the hands. Second one cone. Cone also 3-dimensional object. Third one circle. Yes, circle is 2-dimensional object. Circle is 2-dimensional object. Coming to question number 3, among these 3D shapes, I think see third question, fourth question, fifth, sixth, I think all the concept based questions can be filled by you because we have already discussed the concept. Okay, let us finish as early as possible. Third one is 3D shape. Among the 3D shape is triangle, right angle triangle, equilateral triangle, triangular pyramid. Triangular pyramid is 3D shape. Triangular pyramid. Okay, question number 4. That is among the 4 which is not 3D shape. 3D, it is not a 3D shape. Matchbox is 3D shape, ball is 3D shape, surface of ball, gas cylinder. So except the surface of ball, remaining all we can lift. So surface of ball is 2D shape. Surface of ball. Okay, now this one, for example, board. Now question number 5. Cuboid faces are in the shape of cuboid. While you are observing the cuboid maximum having the rectangle shape. In sometimes the sides can be in square also. So square and rectangle. We can write the cuboid with the square and rectangle. Both we can write. Now coming to question number 6, that is given that all the faces of the cube are in the shape of faces of the cube. Cube is occupied by or formed by squares. Cube is formed by squares. Now seventh question, the base of cylinder. Base of cylinder, I told you the height and base of the cylinder is circle. Base of cylinder is circle. Okay, right. Now next question. Another name of tetrahedron, very important. Another name of tetrahedron is nothing but a triangular pyramid. Triangular based pyramid. Triangular based pyramid. Okay, na? So for this we can draw one diagram also. So this is called tetrahedron. This is called tetrahedron. Now question number 9. The ninth question is given that the faces of tetrahedron in the shape of faces of tetrahedron, each shape, when you are seeing that every side of the tetrahedron, it will be in the form of triangle. It will be in the form of triangle. Okay, now next one, 10th question, that is the solid shape which has unbroken curved surface. Unbroken curved surface means the solid only formed by the curve. For example, while you are observing the cone and cylinder, both are having the curved surface which is breaked by the base circle. Okay, so curved area with having flat area. So it is not completely the curved surface area. It is not completely the flat surface area. But you are asking that only unbroken curved surface area is nothing but sphere. Only one shape, ball. Ball is nothing but sphere, which is unbroken curved surface area. Question number 11. The relation between the faces, vertices and edges. Euler formula you should remember. Faces plus vertices equals to edges plus 2. This is the Euler formula which derives the relation between the solid shape, nothing but which are bounded, which are formed by the flat surfaces. Okay. Now 12th question, that is if the number of faces are 6, and the number of vertices are 8, number of edges are 12, then the shape is, so faces are 6, cuboid, edges 12, cuboid, and vertices also 8. So it can be cube or cuboid. According to the options, it is given that cube. Among the 4 options, we are having only cube, so we are going through the option 4, cube. Let us discuss about the exercise 1 problems. The first question is given that the area of equilateral triangle whose side is 4 centimeter. Now here remember that area of equilateral triangle is root 3 by 4a square, where a means side of an equilateral triangle. We know that equilateral triangle, all sides are equal. Here also given the side of equilateral triangle is 4 is given. So substitute in the place of a 4 square. 4 square means 4 into 4. Numerator 4, denominator 4 cancelled. 4 into root 3 is 4 root 3. Therefore, the area of equilateral triangle which is having the side 4 centimeters is nothing but 4 root 3 centimeters square. Option 4. Now the second question. The area of rectangle, length and breadth. Area of rectangle formula. What is the area of rectangle formula? Length into breadth. Length value is 8 centimeters. Breadth value is 4. 8 into 4, 32. 32 centimeters square. If it is a questions are given in meters, we have to write meter square. Problem number 3. Yeah. The area of a triangle, height 6 centimeters, base 8 centimeters. What is the area of triangle? Half base into height. What is the formula of area of triangle? Half base into height. Now in the question, the height is given 6 centimeters, base 8 centimeters. Base 8, height 6. So 2 table 8, 4 times 6 4s are 24 centimeter square. Okay, because the measurements are given in units, centimeters, so centimeter square. If it is given in meters, we should write meter square. Okay, question number 4. The fourth question, area of square of the side. Area of a square side into side but side is given 10 centimeters, 10 into 10, 100 centimeter square. These are all very easy problems, fundamental problems. I think you have already got it in your previous classes and present class also. So just focus on the formulas and go through it. So question number 5. Area of right angle triangle whose sides are 15, 20, 25. Right angle triangle whose sides are 15, 20, 25. Obviously 25 is the larger side. 25 is the larger side. Am I right? Okay. 15, 20, 25 right angle triangle. We know that area of right angle triangle formula is half into base into height. If you take base 15, height will be 20. If you take base 20, height will be 15. Substitute. We are not taking 25 hypotenuse, that is. So 20 into 15, 2 table 20, 10 times 10 into 50, 150 centimeter square. Okay, na? Right. Now let us move on to the next problem. Before that, let me clean the board. Right. So problem number 6, children. The sixth problem is given that, the problem number 6 is given that the diameter of two circles are in the ratio 2:3. I am taking the two circles diameters D1 is to D2 equals to 2:3 it seems. The ratio of the diameters are given. Then the ratio of the heights of their volumes are same or not. Heights of the volumes are in the same ratio. Okay, na? So heights of the volume for circle, diameters only for circle, its 3D shape will be sphere. Okay, na? Now the sphere formulas, sphere curved surface area formula is 4 pi r square, total surface area formula also 4 pi r square, and volume is 4 by 3 pi r cube. Volume is 4 by 3 pi r cube. Now coming to the diameter 2:3, we are asking about the question that then the ratio of their heights, if the volumes are same. If the volumes are same, what about the heights? Now I am taking the volumes like diameter is, let us take D1 and D2 as D1 as 2x, D2 as 3x. So D1 value is 2x, D2 value is 3x. Okay, na? Now coming to the radius, radius is exactly half of the diameter. Now from the first question, radius is x, here second one is radius is r1, here r2 is 3x by 2. Here 2x by 2 to cancel x, here 3x by 2 or half of 3x. Next. Now if the areas are volumes, am I right? If their volumes are same, according to the volume formula for sphere, 4 by 3 pi r cube. R cube means I am taking r1 cube. Here also 4 by 3 pi r2 cube. Both sides 4 by 3 pi, 4 by 3 pi cancel. R1 cube, R2 cube. R1 value is nothing but x, x cube. R2 value is nothing but 3x by 2 whole cube. That implies x cube is equals to cubing of this number. 3 cube is 3 into 3 into 3, 27. Here x cube by this one, 2 cube value is 8. 2 cube value is 8. And we should find out the ratios, right? Ratio of their heights. Heights ratio we should take. But height, how can you take in a cylinder? Height is nothing but diameter we should take. Height is nothing but diameter we should take. Okay, na? Diameter in the place of, okay, let me find out that R1 is to R2 ratio first. Here R1 is to R2 will be, yeah, D1 is to D2 ratio 2 is to 3 only. Height also 2:3. If the volumes are equal, heights can be changes, right? So radius can be different height. sorry, we are taking the spheres, but here it is giving clearly that that is cylinders, two cylinders. If their volumes are equal, we should find out their heights. Now cylinder formulas we should apply. Cylinder formula pi r square h. So first one pi r1 square h1, second one pi r2 square h2. Okay, na? Both sides pi cancel. R1 according to this 2x by 2 is x. I am taking that x square. H1 is as it is. R2 means 3x by 2 whole square into H2. Now H1 by H2, because H2 is multiplying when you transpose device, that is equal to here 9x square by 4. This is x square multiply when you transpose device. So 9 by 4 is nothing but 9:4. Okay? The answer of ratio of the heights H1 by H2 is equal to 9:4. Let us move on to the question number 7. Seventh one. Right. The seventh question is given that the area of trapezium whose parallel sides are of the length of 7 and 9 centimeters and the distance between them is 6. Area of trapezium area formula. What is the area of trapezium formula? Half h into a plus b. I told you already, a and b are length of the sides. H is the distance between parallel sides. Now distance between parallel sides, h is 6 centimeters, length of sides 7 and 9. So 6 centimeters, length of sides 7, 9, 7 plus 9. So 2 table 6 3 times, 3 into 7 plus 9 is 16, here nothing but 48. Therefore the area of trapezium is 48 centimeters square. First option. Let us move on to the question number 8. Okay, now the 8th problem is given that the area of rhombus whose diagonals, area of rhombus formula is given directly half d1 d2. Here also given the d1 d2 values. Try to substitute in the formula and find out the answer. Let us move on to the question number 9. Area of circle radius. Area of circle formula what? Pi r square. Radius also given. That is also you can directly substitute in the formula. You will get it. Okay, na? Next, go to the problem number 10. The 10th problem is given that a solid iron rod is in the shape of cylinder. Cylindrical shape, it is already mentioned. So its height is 11 centimeters, base diameter is 7 centimeters, and the value of 50 rods, volume of 50 rods, not value, that is considering as volume. So question number 10. The cylinder having the height and base radius or base diameter is given. Cylinder having the height is 11 centimeters and the base diameter is having 7. Diameter means entire 7, but radius is nothing but 7 by 2. Okay, na? Now we need to find out the volume of 50 rods. Volume. What is the volume formula for cylinder? Pi r square h. Here how many rods is asking about? 50 rods. 50 into pi value is 22 by 7. R value is 7 by 2. So r square means 7 by 2 into 7 by 2 and height is 11. So 7 cancel. 2 table here 11 times. 2 table here 25 times. So what are the values we are having? 25 into 11 into 7 into 11. So try to multiply all of them. We will get the final answer. So 11 7 77 into 275. 25 into 11. 25 times 250 plus 75. So just try to find, just multiply answer, you will get the answer. Okay, check in your options. Yeah, okay, now just find out the answer. Let us move on to the next question. 11th problem. Okay, the 11th one is given that the area of sector of radius 21 centimeters, angle between two radii is 60 centimeters. So sector is nothing but the shape, nothing but one of the part of a circle. One of the part of a circle, and the two radius length is given, that is 21 centimeters, and the angle between two radius is 60 degrees. Now here you should remember the formula to identify the area of sector. So area of sector formula, x degrees by 360 degrees into pi r square. X degrees by 360 into pi r square. So x is nothing but 60 degrees by 360 degrees into pi value 22 by 7. Radius. Radius is 21 into 21. Okay, na? So try to cancel 60 table here 6 times, 1 by 6. 7 table here 3 times. 3 table here 2 times. 2 table here 11 times. So answer is 11 into 21. So it is nothing but 241. 241 is our required answer. 210 plus 20, sorry, 231, right? 231. Yeah, 231. 210 plus 21, 231. So this is the area of the sector. So here you should remember the formula, like area of sector is equal to x degrees by 360 into pi r square. Let us move on to the problem number 12. Okay, no? The 12th one is given that the side of an equilateral triangle is, we should find, but the area is given 64 root 3. Now remember the formula of equilateral triangle area is root 3 by 4a square. This area is given that 64 root 3. Now transpose the numericals that side, that is 64 root 3 into root 3 by 4. When you transpose it will be 4 by root 3. So root 3 cancel. A square is equal to, I can write 64 as 8 square plus 4 as 2 square. Okay. So A is equal to 8 2 is 16. Clear, children? Right. This is the side of a equilateral triangle. Okay. Let us move on to the question number 13. Okay, the 13th problem is given. The 13th problem is given that if the perimeter of rhombus is 100 centimeters, we know that perimeter of rhombus nothing but all sides are equal in rhombus. All sides are equal in rhombus. If the perimeter of rhombus is 100 centimeters, what about the each side? Rhombus is nothing but sum of 4 sides. All sides equal means 25, 25, 25, 25, nothing but 100. So each side of the rhombus is 25 centimeters because the perimeter is 100 centimeters and one of the diagonal is 40 centimeters. Then the area of rhombus. One of the diagonal is 40 centimeters. Then area of rhombus. But here, to find the area of rhombus, we know the formula d1 into d2. But one of the diagonal is one of the diagonal is 40 centimeters. So this entire one 40, and we know each side is 25. We know according to the property of a property of a rhombus, diagonals bisect each other. Now total length is 40, so this half of the piece is 20. Now this will be in the form of like a right angle triangle. We need to find out the second half of the diagonal. Okay, by using the Pythagoras theorem, hypotenuse square. This is 25 square is equal to side square plus this one also side square. According to the Pythagoras theorem, hypotenuse square is equal to side square plus side square. 25 25s are 625, 20 20s are 400 plus x square. And you transpose 400 this side minus 400. 625 minus 400 is 225. 225 is nothing but 15 square. So x value is 15. This half of the part is 15, then the entire part is diagonal 2 is 30 centimeters. Diagonal 1 is 40 centimeters. Now area. Area of rhombus is equals to half d1 into d2, that is equals to half into 40 into 30. 2 table 20 times, there are 600 centimeter square. Okay, na? So let us move on to the next problem. Okay, 14th one. The area of an equilateral triangle again is given its perimeter. Same question, 12th question. What is the side we are getting there? 16. Then perimeter is nothing but sum of all sides of equilateral triangle. All sides equal 3 into 16. 48 centimeters will be the answer. You can check by your own. Now question number 15. A wire of the length 50 centimeters is cut into the shape of two pieces around the ratio 3:2. The wire length cut into the shape of 3:2 and the total length is 50 units. 50 units is dividing into 3:2. That means 3x plus 2x. Total length is 2x plus 2x is equals to 50. Then 2x plus 3x value 5x. 5x value is 50. Then x value 10. That means 3x value 3 tens are 30. 2 tens are 20. The wire is cut into the two parts 30 units or 20 units, like 30 centimeters and 20 centimeters, whatever. If the smaller piece is bent into the form of square, smaller piece means 20, is bent into the form of square, all sides are equal. So 5, 5, 5, 5, 4 5s are 20. Each side is 5. Then the area of square, 5 into 5, 25. Area of square formula, side into side, nothing but 5 into 5, 25. Question number 15. That is, sorry, this is only the 15th one, now 16th one. Now 16th question, that is, the ratio of length and breadth of rectangular field is 4:3. That means length you can take it as 4x, breadth you can take it as 3x because of 4:3. Okay, the diagonal is 200 meters. Then the area of the field, diagonal means the length of the line segment which is connected to two opposite vertices. This is the diagonal. Let us consider this is 2x, this is 3x. Breadth is 3x, length is 4x, and the diagonal is 200 meters. And if you observe that one, this is half of the diagram. It is a right angle triangle. Again, same formula, hypotenuse square is equal to side square plus side square. So 200 square is equals to side square plus side square. So 202 square is 4. 2 zeros becomes 4 zeros. 3x whole square means 9x square. 4x whole square means 16x square. 9 plus 16, 25x square. So x square is equals to 40,000 by 25. Okay, na? So 25 in 400. 25 in 100 4 times. 400 16 times. It is 1600. So 16 is a square number. So 40. 40 40s are 1600. Okay, na? Therefore x value 40. Then length, what about the length? 440 is 160. So length will be here 4 into 40 160 and breadth is 3 into 40 120. Therefore area is equals to length into breadth 160 into 120. So 16 12s, 16 10s 160, 2 16s are 32. So 192. So 19200. This is the area of the required rectangle. Okay, let us move on to the next problem. Now 17th one. The problem number 17th is given that the area of square whose side is the diameter of the circle of area for s square pi is, okay, so area of circle is given and whose diameter is equals to side of a square, and area of circle formula pi r square, and its value is given that 4s square pi. 4s square pi. So pi is cancelled. R square is equals to 4s square. R value is 2s. R value means radius value is 2s. What about the diameter? Diameter value is 4s. 2 times of radius is nothing but diameter. Now this diameter is equals to area of square. So area of square is equals to 4s into 4s, 16s square. Let us move on to the problem number 18, that is the circumference of a circle. Circumference and perimeter both are same. That is nothing but 2 pi r formula in which 3 by 4 rectangle is inscribed. 3 by 4 rectangle is inscribed. For example, let me draw the diagram, very important question. A circle is there. In that 3 by 4 rectangle is inscribed. That means length is 4, breadth is 3. Like this inscribed. Now, to find the circumference of a circle, we need the formula 2 pi r. That means 2 value we know, pi is nothing but 22 by 7. Radius we should find. To find the radius, the length is 4, breadth is 3. By Pythagoras theorem, the diagonal will be 5. The diagonal is nothing but, according to the diagram, the diagonal of a rectangle is equals to diameter of a circle. Okay, na? Diameter of a circle is 5 units we got, and radius is equals to 5 by 2. Substitute here. 2 cancel. 5 into 22 by 7, 5 pi. 5 into 22 by 7, 22 by 7 we can write as this pi because answers are given pi. Okay, 19th question. The length of the rectangle is increased by 20% and the breadth of the rectangle is decreased by 20%. Then the resulting area will be increased or decreased. Whenever the length and breadth are having the same measurements, obviously decreases only. 20% increase, 20% decreases means the final result will be decreased. But the values are different. 20% increase, 10% decrease means values will be different. That can be increase or decrease, we cannot say. But exactly 20% decrease, 20% decrease, overall is decrease. How we are finding that one? By decrease formula, right? 20% into 20% by 100. That is equals to both the numerator 2 zeros, denominator 2 zeros cancel. 2 into 2, 4% is decrease. 4% is decrease. Now, let us move on to the problem number 20. Problem number 20. Yeah, 20th problem is, in a parallelogram ABCD, AB equal to 50 centimeters and the perpendicular height is equals to 7 centimeters. So parallelogram ABCD AB equals to 50 centimeters and its perpendicular height is 7. This one is 7. Okay, na? Next, AD is 25 centimeters. AD is 25 centimeters. Its perpendicular height we need to find. Okay, na? Right. Now, according to the parallelogram, base and height. Base and height, if you know, we can write it its area. Area of a parallelogram is equal to base into height. And here also, base into height. For if you take the base 25, height we should find. Now 25 table 50 2 times 2 sevens are 14 is the required answer. Okay, right. Let us move on to the second 21st one. The curved surface area of the cone is 4070 centimeter square. Curved surface area of cone, that formula is pi RL, 4070 centimeter square, and its diameter is 70. Let us find the slant height. So 22 by 7, diameter 70 means radius is 35. Slant height we should find it. So transpose everything that side, you will get the answer. So 22 by 7 becomes 7 by 22 and 35 becomes 1 by 35. Okay. So after cancellation, 5 table here 7 times, here 5 table 5 8s are 5 1s are 5, 5 4s 20. Again 2 table here 11 times, 2 table 407 times. Or any other cancellation you can do, 7 cancel. So L is equal to 37. After cancellation 11 table, 37 times. Let us move on to the problem number 20. Okay, that is the radius of the circle whose area is equals to the sum of the areas of two circles. Okay, one circle area pi r square is equal to sum of the area of two circles, pi r1 square, pi r2 square, that is right. And the radius also given, that is 512 centimeters. So I am taking pi as a common term, so r1 square plus r2 square I can find. Pi cancel, capital R square is equal to 5 square plus 12 square. 5 square value 25, 12 square value 144, nothing but 169, 13 square. Therefore, radius of the larger circle is 13 centimeters. Last question to this synopsis and to the entire 7th class syllabus. 23rd question. The 23rd one is given that if the length of the rectangle is 1 kilometer more than its width and its perimeter is 14 centimeters. So length of the rectangle is 1 kilometer more than its width. Width means breadth, b plus 1. Okay. Next, and its perimeter is 14 centimeters, then the area of a rectangle. So what is the perimeter formula? 2 into L plus B, that is 14 centimeters is given. In the place of L, you can write b plus 1. B value as it is b is equals to 14. 2 table 14, 7 times cancel. B plus b, 2b plus 1 is equals to 7. 2b is equals to 6. B value is 3. So L value is 4 because it is 1 kilometers more than it. Therefore, area is equals to length into breadth, 4 into 3, 12. Okay. So that's it for today, children. Thank you one and all. Have a nice day. Bye bye.